Alright, so this is the second side of the average value of a function notes, Unit 7. Alright, and we're going to go through these quickly. I've actually got the notes here up and filled in. I just want to talk them through, make sure that you notice a few things. So the word average pops up in two different ways in AB calculus. Right? So it pops up, we've actually already seen this when we talked about the average rate of change. Average rate of change, or AROC. So the average rate of change of a function is defined as where you were at the end minus where you were at the beginning divided by b minus a. Right? So average rate of change is another way of saying the slope of the function, the average slope of the function. We just learned on the front side that the average value has this definition, 1 over b minus a, of the integral from a to b of the function f of x. Now, the interesting thing that even though this word average pops up in two different places, it really is the same exact concept that we're talking about. But you need to be clear that if somebody's asking for the average rate of change, you're giving them this. If somebody's asking for the average value, you are giving them this. But they're the same in here. Follow this along. So if you take the definition, the mathematical definition we've just given you, that the average value of a function is 1 over b minus a of the integral, right, then we can take the antiderivative, and notice in the notes here that the function that we're using is the derivative of the function, right? And we're doing that so that when we take the integral, we know what that is. Well, the antiderivative of the derivative is the function, right? So if we evaluate this, the integral is going to be the function f of x from b to a, which is f of b minus f of a. And then all of that was times 1 over b minus a, or all of that divided by b minus a. And then this right here is the formula for AROC, the average rate of change. So the average value of f prime, of the derivative of f, is the same thing as the average rate of the function. All right? So the average, say that again, the average value of the derivative of the function is the same thing as the average rate of change of the function. All right. So an example down here at the bottom. Ooh, there we go. So Billy the caterpillar traveled on a number line. His position function was given by this. His average velocity in the first 3 minutes of travel. So two ways to find this. First way to find this is by finding the caterpillar's change in position divided by the change in time, which is AROC, right? Average rate of change. So we're looking at the interval in the first 3 minutes. So at 3 minutes, plug this into the position function. We get 3 cubed, which is 27, 4 times 3 squared, which is 36, plus 5. So at the end of 3 minutes, caterpillar is at 68 feet from the starting. Actually, at 68 feet from some point defined as 0. At the beginning, at S0, the caterpillar was at 5. So his average rate of change was, well, he went 68 minus 5 feet in 3 minus 0 seconds, or he went 21 feet per minute. The Second way to do this is to find the average value. Now the average value, again, is related to the average rate of change. It's the average value of the derivative is equal to the average rate of change of the function. So the derivative of our position function is the velocity. We take the derivative of this here and we get 3t squared plus 8t. So if we're finding the average value of his velocity function, we're looking for the average velocity. So this describes his velocity over time. And then we plug it into the formula we learned on the front side. So we're going to do 1 over b minus a, 3 minus 0. So it's 1/3 of the integral from 0 to 3 of the velocity function, which is 3t squared plus 8t. We take the antiderivative of 3t squared plus 8t, which is t cubed plus 4t squared, and we're going to evaluate that from 3 to 0, and then you can see the math that's done here, and we get, again, using the average value calculation, we get 21 feet per minute. And we're done with the notes.